The James Webb Space Telescope is shaking up everything we thought we knew. For ages, scientists have said that the universe started with the Big Bang about 13.7 billion years ago. But new discoveries are making us rethink this. Time, which rules our lives and has puzzled both scientists and thinkers, is at the center of this debate. Famous physicist Michio Kaku, known for his bold ideas, has made a shocking statement. He says, "Time doesn't exist." This idea goes against what we experience every day, but recent findings from the James Webb Telescope are giving his claims some weight. So, what did the James Webb Space Telescope find? And how does it support Kaku's mind-blowing theory? Let's dive into Michio Kaku's ideas about the non-existence of time and how the James Webb Telescope is changing everything we thought we knew. Launched on Christmas Day in 2021, the James Webb Space Telescope follows in the footsteps of the iconic Hubble Space Telescope, but with upgraded features and capabilities. Positioned in the vastness of space, it acts as a window into the universe's deepest mysteries. It's like a time machine equipped with powerful infrared tools, allowing it to peer into the fabric of time itself. With its cutting-edge technology, the James Webb Telescope has been on a cosmic voyage since its launch, exploring realms previously beyond our grasp. It has been unveiling the ancient enigmas of distant galaxies and celestial bodies, as well as relics from the universe's infancy. Once hidden and largely unknown, these mysterious entities now take center stage in the universe's evolution. For decades, the prevailing theory described a universe born from a massive explosion eons ago. However, the images captured by JWST have since challenged this narrative, depicting a cosmos that surprises us at every turn. In the midst of this scientific revolution, astronomers like Alison Kirkpatrick from the University of Kansas confront profound questions. Their understanding of cosmic evolution, once firm, now faces uncertainty. The galaxies observed by JWST refuse to conform to our well-known and conventional theories, thereby forcing us to rethink our perception of our universe's origins and fate. To simplify the complex puzzle presented by the James Webb Space Telescope, let's envision the universe as an expanding balloon. According to the expanding universe concept, as galaxies move away from us, their light should appear to stretch, making them look larger. However, the JWST images reveal a surprising twist. Galaxies at great distances seem to be about the same size as those nearby. It's as if you expected distant friends to look like specks on the horizon, but instead, they're right beside you, just as large as life. Similarly, JWST images reveal galaxies that are about the same size as those near us. This defies expectations, especially when you consider that these galaxies are often brighter and more massive than our Milky Way. But these peculiar findings do not end here. The galaxies seen by JWST appear 2 to 3 times smaller than those observed by the Hubble Space Telescope, despite being more luminous and massive. Equally, these galaxies exhibit significantly higher redshifts, indicating they are moving away from us at a faster speed. Back in 2014, scientists noted this inconsistency when analyzing Hubble's images. Galaxies with redshifts up to 5 seem to behave as expected in a non-expanding universe. This trend continues with JWST, even for galaxies with redshifts as high as 12. In simpler terms, JWST images suggest that galaxies appear the same size regardless of their distance from us. This challenges the idea of an expanding universe, suggesting that redshift might simply be a function of distance. If we stick to the Big Bang theory, this poses a perplexing question. Are these distant galaxies unimaginably small, counterbalancing the supposed illusion of an expanding universe? It's a bit like imagining a grain of sand shining as brightly as a spotlight in the vastness of space. Take, for instance, the galaxy named GH2, which the James Webb Space Telescope, JWST, observed. Despite being much brighter than our own Milky Way, GH2 is incredibly compact, spanning a mere 300 light-years compared to the Milky Way's vast 50,000 light-year expanse. This means that the brightness of GH2 per unit area is a staggering 600 times greater than the brightest nearby galaxy. Intriguingly, GH2 and other newly discovered galaxies are not only bright, but also incredibly dense, thousands of times denser than the galaxies we are familiar with. These dense, powerful galaxies challenge our understanding of the universe's expansion and the Big Bang Theory, shaking the very foundations of our cosmic knowledge. Astronomers and cosmologists are as shocked as they are excited about these discoveries. The Hubble Space Telescope has captured images of many such dense and powerful galaxies, likened to the legendary Mighty Mouse from old cartoons, emphasizing their small size yet immense power. To make sense of these unusual compact galaxies, scientists have proposed a fascinating idea. It's similar to playing with a magical toy car that starts incredibly small, like a centimeter in length, but has the mass of a real SUV. They suggest that these microgalaxies collide with each other over billions of years, gradually merging to form the larger galaxies we observe today. However, the JWST has conducted a thorough examination of these galaxies and surprisingly found no evidence of cosmic collisions. If galaxies were indeed crashing into each other, we would expect to see some signs of chaos or distortion, much like a car after a minor accident. However, this is not what the JWST has observed. Instead, it reveals galaxies that are remarkably smooth and orderly, resembling those nearby. There is a distinct lack of any visible damage or evidence of collisions among these galaxies. One study, known as PANIC, highlights this phenomenon, pointing out that there are 10 times more of these pristine spiral galaxies than theorists had predicted. This discovery is akin to discovering a bustling highway with fast-moving cars but no accidents. It challenges the collision theory, which suggests that these small galaxies merged to form larger ones. If these galaxies did not grow in size through mergers, it implies that they were not small to begin with. Moreover, the expected optical effects from an expanding universe seem to be missing. Without these expected illusions, the concept of expansion loses some of its support. This has led to growing unease among proponents of the Big Bang Theory, as the presence of these small, smooth galaxies suggests that the universe might not be expanding after all. If this is the case, the Big Bang Theory faces a significant challenge, forcing scientists to rethink our understanding of the cosmos. There is another intriguing aspect to consider: the age of stars. According to the Big Bang Theory, everything came into existence following a massive explosion. However, if these galaxies existed before the supposed Big Bang, it would mean that the explosion didn't happen. This could completely revolutionize our understanding of the universe's origins. Think of the James Webb Space Telescope as a time machine, as Michio Kaku describes it, capable of peering billions of years into the past, capturing images that illuminate the universe's origins. This incredible device doesn't capture photos in our familiar visual spectrum. Instead, it focuses on the infrared, revealing the colors of galaxies so distant that we could never see them with our naked eye. The fascinating part is that these colors aren't just beautiful. They tell a story about the age of the stars in these galaxies. Young, fiery stars blaze with vivid blue hues, while their older, cooler counterparts, similar to our Sun, glow in hues of yellow and red. By studying these colors, astronomers can estimate the age of the star populations in these distant galaxies. According to the Big Bang Theory, the galaxies farthest away in the JWST images represent a cosmic snapshot from around 400 to 500 million years after the universe's birth. However, some of these galaxies seem to house stars that are over 1 billion years old. This poses a significant problem because nothing should be older than the Big Bang itself, according to the theory. Another expectation of the Big Bang Theory is that as we look farther into space, which means looking further back in time, we should see fewer and fewer galaxies until we reach a point where there are none, a cosmic dark age. However, it seems to be a different story. Galaxies as massive as the Milky Way were already quite common just a few 100 million years after the supposed Big Bang. The new images indicate that there are at least 100,000 times more galaxies than predicted at high redshifts, more than 10. This raises the question: how could so many large galaxies form in such a short time? The answer is, They probably couldn't, at least not under the constraints of the Big Bang Theory. This is why these discoveries are challenging the very foundation of our understanding of the universe. Additionally, there's intriguing information that suggests the Big Bang Theory may be off the mark on quite a few things. Believe it or not, recent research has thrown an intriguing curveball into our understanding of cosmic origins, suggesting that the well-respected Big Bang Theory might be off on several fronts. It's not just a single or a couple of discrepancies. Astonishingly, this theory appears to miss the mark on a whopping 16 predictions according to recent studies. The only prediction it accurately forecasts is the abundance of deuterium, a type of hydrogen variant. But wait, there's more to this intriguing deviation from predictions. The Big Bang Theory, revered for decades, overestimates the quantities of helium by double and lithium by a staggering 20 times compared to what we observe in the universe. Additionally, this foundational theory stumbles when it comes to explaining the existence of massive structures in the cosmos. According to its principles, these structures should not have had enough time to form since the universe's inception. Adding to the puzzle, the theory struggles with its predictions regarding the density of matter within the universe. But here's an unexpected twist. Remember those supposed asymmetries in the cosmic microwave background that were previously considered non-existent? Recent findings indicate that they do exist. It's similar to a cosmic plot twist, shaking the very foundations of our established cosmological understanding. Now, what's the remedy for these cosmic mysteries? The James Webb Space Telescope, the technological marvel that could potentially unlock the answers to these perplexing contradictions. While these discrepancies might seem like small deviations in the vast expanse of the cosmic jigsaw puzzle, they obstruct our comprehension of the big picture and leave us with an incomplete understanding of the universe's nature and origins. These anomalies unearthed by recent discoveries are more than just glitches in our cosmic understanding. They shake the very foundations of what we've long believed about the formation and evolution of the universe. They challenge not just our comprehension of cosmic structures, but also the fundamental fabric of space-time itself. This, in turn, has profound implications for our understanding of universal expansion, gravitational waves, dark matter, and even the ultimate fate of the cosmos. Consider how a seemingly simple discrepancy like the density of matter could reshape our entire understanding. If this density differs from our predictions, it could reshape our understanding of how galaxies form and evolve, thereby altering our perspective on the role of dark matter in this process. Similarly, the unexpected asymmetries in the cosmic microwave background could rewrite our understanding of the universe's initial conditions and the speed at which it expanded. But it doesn't stop there. These inconsistencies even ripple into our understanding of time itself. Currently, our perception of time is intricately linked to the evolution of the universe from the Big Bang onward. However, if the Big Bang Theory is found lacking, it could prompt us to reevaluate how we perceive time, its flow, and its interconnectedness with space. Think about it. These findings could lead to a paradigm shift in our understanding of space-time, comparable to when Einstein introduced his theory of relativity. We could be on the brink of a fresh understanding of the cosmos, where we'd need to recalibrate our cosmic clocks and redefine our cosmic compasses. The universe, it seems, still has a few surprises up its sleeves. Don't you think? Is time truly an illusion? Have you ever pondered if time as we perceive it truly exists? Or is it merely a construct we've created to delineate the past from the present? It's a weighty question, but bear with us. There's a theory that suggests time might be an illusion, a construct shaped by our human memories. According to this idea, everything that has happened or will happen is unfolding right at this moment. It's a concept that might seem a bit strange at first glance, but let's delve deeper into it. Naturally, we think of time as flowing forward. However, the laws of physics don't mandate this direction. They work just as effectively whether time moves forward or backward. For instance, the Big Crunch theory proposes that when the universe finishes expanding and begins to contract, time might reverse its flow. As the universe shrinks, it could get hotter, resembling a Big Bang in reverse. But what happens after the Big Crunch? That's a question that has puzzled scientists for some time. Some theories suggest that a new universe may emerge from a fresh Big Bang, while others propose that our universe might reappear somewhere else entirely, similar to a cosmic bubble popping into existence. There are even theories suggesting that this cycle might repeat itself endlessly, leading to the creation of countless universes. This intriguing possibility of time moving forward or backward has led some scientists to a daring conclusion. Time, as we understand it, is merely a human construct. They argue that we inhabit a block universe where space and time are intertwined, a notion supported by Einstein's theory of relativity. In this scenario, all events, past, present, and future, have their own coordinates in four-dimensional spacetime. What does this mean for us? It suggests that everything, including the past and the future, is as real as the present moment. They exist somewhere in spacetime, waiting to be experienced. Eminent physicist Max Tegmark beautifully summarized this concept, stating that we could view our reality as a three-dimensional place where events unfold over time, or as a four-dimensional place where everything just is and nothing changes. While it may be challenging to wrap your head around such profound ideas, isn't it fascinating to contemplate such questions? It highlights the awe-inspiring and mysterious nature of our universe. Julian Barbour, a British physicist, offers an intriguing perspective on time. He sees our reality as a sequence of distinct now moments, like individual snapshots in a photo album. Each moment, according to Barbour, is its own unique now. He argues that our perception of the past is merely a construct of our brain's memories. We feel like we have a past because we remember it. However, the actual concept of the past, according to Barbour, might be an illusion. Barbour further elaborates on this concept through his spatial theory. In this theory, each now moment exists in a place within a vast landscape, which he whimsically calls Platonia. In Platonia, every point represents a now, and this landscape follows perfect mathematical rules, making it timeless. This perspective connects back to Albert Einstein's theory of spacetime, which is central to our current understanding of the universe. However, the implications of Einstein's theory and our comprehension of it have raised critical questions. What if Einstein's concept of spacetime was erroneous? Could discarding it entirely provide us with a clearer comprehension of the universe? The idea of discarding a well-established theory may seem startling, but it's important to understand that the realm of science thrives on such revolutions. Theories are continually challenged, refined, and sometimes entirely replaced. It's through this perpetual cycle of inquiry and discovery that science progresses. A look back into history shows us how this process has unfolded over time. For instance, the geocentric model, which placed Earth at the center of the solar system, was widely accepted for over 1,000 years. Then, Nicholas Copernicus proposed the radical idea that Earth is just another planet orbiting the Sun, eventually replacing the geocentric model. Following Copernicus, Isaac Newton introduced a new understanding of gravity. He proposed that all objects with mass have a gravitational attraction towards each other. According to Newton's theory, the Earth orbits the Sun and the Moon orbits the Earth because of their mutual gravitational pull. Do you believe time truly does not exist? Let us know your thoughts in the comments below. See you in the next video.